Students, if you watch the whole video, the topic is real easy and it seems too natural to you. So, can you guess about this topic today? Yes, absolutely, you are right. The today now our topic is numbers. Today we are going to discuss about the topic is numbers, but there are also some twist is there. So let me see that. So generally the numbers we expose in different types. For example, real numbers, whole numbers, natural numbers, integers, and rational numbers. So before we are getting into the topic of the real topic, so we just go to the kindergarten. So in kindergarten, teacher used to explain some rhymes. For example, do you know remember the rhymes about 1, 2, 3, 4, 5, once I got a fish alive. So for example, 1, 2, 3, 4, 5, and this go on. These numbers are called natural numbers. These numbers are called natural numbers. So shall we go for the topic? So this number is natural numbers 1, 2, 3, 4, 5. A number in the format of 1 to infinite are called natural number. So first we will round it off. So we will make oval shape over. Okay. So the next pattern of the number is nothing but the natural number with 0. A number added with 0 is called whole number. So whole number is coming with 0 and adding to the natural number. So a number is start from 0 to infinite is called whole numbers. So natural number, then natural number with 0 is called whole numbers. And one more pattern of number, the positive natural number along with negative natural numbers and 0 is called negative numbers. For example, minus 3, minus 25, minus 395. You can take any number, no issue of it. So natural number, positive natural number, negative natural number with 0 is called integers. So it's called integers. So integers is nothing but positive numbers, negative natural numbers. Whole number with negative natural number. We can simplify like this. Whole number with negative natural number. Okay, shall we go for the next one topic? For example, is there any numbers between two integers? For example, integer is called positive size infinite, negative size infinite, and 0. And we know that 0 is neither positive nor negative. It's not a positive number, it's not a negative number. Because 0 is neither. It's a neutral number, it's not adding with anyone. So now, is there any two numbers between any integers? For example, if you take 0 and 1, these two numbers are integers. So now we come to the natural number, whole number, and integers. So now you take the two numbers of integers. Two integers is there. Between there, any numbers is there? Of course, we used to say that half, 1/3, for example, 0.7, 0.8. We used to say few numbers. So these numbers we used to call, for example, 1 and 3, we used to call this number as, how would you call the number? Fractions. Good. The last year you studied about it, right? And these numbers, how would you call it? You call this as decimals. So the fractions and decimals are non-integers. So the fraction and decimals are non-integers. So now we could call that integers, fractions, and decimals or the numbers or combinations of rational number. Or the combinations of rational number. So today we are going to discuss the topic of natural, whole numbers, integers, and finally we are going to get into the topic of rational number. Okay, fine. So before getting to the topic, let me have a small activity. Now you might be seeing some dots over there, right? For example, orange, brown, orange, blue, black, yellow, and a few more dots also there. So now we know to identify the number of same color circles out of the total number of circles in the given image, right? So here, use that here, the number of orange colored circles, 1, 2, 3, 4, 5. The number of orange colored circles are 5 out of 16. 5 out of 16. So the number of yellow colored circles are, how many is there? Yeah, this only one. So 1 out of 16, which is represented as, for example, yellow color will be orange color we are representing as 5 out of 16. Yellow color is representing 1 out of 16. This is what we are representing. Similarly, we could show that blue color, brown and black and colors are represented the zone on the paper, like the same. So check out over here. The number of orange color circles are 5 out of 16. Number of yellow color circles are 1 out of 16. Number of black color circles are 2 out of 16. See, 2 is there. So and the number of blue color circles are 5 by 16. So blue is 5 is there. 1, 2, 3, 4 and 5. Yes, 5 by 16. And number of brown circles are 3 by 16. Okay. Now these numbers we are representing by the fractions, right? 5 by 16, 1 by 16, 2 by 16, 3 by 6, 5 by 16 and 3 by 16. These numbers are representing as the fractions. We all know that the numbers or colored circles are in the format of P by Q. Just note down that P by Q. It is have a numerator and denominators. So all the numbers are in the format of the same P by Q format. And where P and Q are integers. 5 also integers, 16 also integers. 1 also integer, 16 also integer. 1, 2, 3, all the quotients numbers are, numerator numbers also integer, denominator also integers. And Q is not equal to, check and through all the Q denominators are 16, it is not equal to 0. So these numbers are called rational number. These numbers we used to call that as rational numbers. So, and the rational numbers we are representing in the format of Q. We are representing the format of Q in the number system of patterns. We are representing in the format of Q, and these numbers are called quotient numbers. These numbers are called quotient numbers, and we all know that natural numbers, and before that what is natural number? We are talking about rational number. So what is the definition of rational numbers? Let me go there. So a number can be written in the form of A by B. So there we are written as P by Q, and A by B is not a matter because numerator by denominator, and where numerator and denominator, so A and B are the integers and B is not equal to 0, which means the numerator and a number should be written in the format of fractions, which means A by B is any integers we can use it. So but the denominator B, which is not equal to 0, it should not be equal to 0, those numbers are called rational number. For example, for the rational numbers we already discussed over the rational number, which is nothing but it included that all the natural numbers, whole numbers and integers. Natural number, whole number, integers, and included the fractions and decimals. We also know that natural numbers can be represented in the zone in the figure. So natural number, how could you represent that? We see that 1, 2, 3, 4, 5, but here we are going to see that 2. For example, we take one number as a 2. 2 we can represent as 2 by 1 or 4 by 2 or 8 by 4. So if you simplify, you will get the same resultant over. So similarly, we can express whole number also in the format of 0, in the format of integer. 0 is a whole number because we added any other number. Positive natural numbers will go natural number, negative number will go to the integer. The only specification is whole number is 0. So we take it as that. 0 can be represented as 0 by 1 and 0 by 2 and 0 by 4. And these numbers, check out over there, it's written in the format of P by Q, where Q is not equal to 0. We have to represent very clearly the denominator number should not be equal to 0. Numerator 0 is not an issue because numerator is 0, whatever the resultant will become a 0. If denominator is 0, what will be the answers? If denominator, any number, if you take the denominator, for example 5 divided by 0, the number is not defined. So any number denominator is 0, we cannot able to define the numbers. So that such kind of numbers will not come into the format. So only the number having denominator is not equal to 0 is called rational numbers. Now the whole numbers. The next you can conclude it with that natural number and whole number with the integers. Integers is nothing but, for example, minus 5. Minus 5 can be represented as P by Q as minus 5 by 1 and minus 10 by 2 and minus 15 by 3. So any number if you take, if we have the simplified form, the resultant will come over. So above the statements we come to the conclude of that, which is nothing but natural number, whole numbers and the integers are also a rational numbers. So all the natural number, whole number, integers are called as a rational number. So we should be very clear about it. So and the next pattern of numbers. So now we know about rational numbers and what are the overview of this given topic. So let me go to the overview of the topic, which is nothing but this is the overview of the topic. So today we are going to see the topic is rational number. Rational number is the classification of this much of chapters will be the topics will be the subtopics. Properties of rational numbers and role of 0, role of 1, existence of inverse, distributive property of multiplication over addition as well as subtraction also the representation of rational number on the number line and rational numbers between two rationals. This is what we are going to see that. The first topic of today we are going to discuss about properties of rational numbers. Properties of rational numbers, it's nothing but closure property, commutative property and associative property. So each properties will be divided into three classifications, which will be whole numbers, integers and rational numbers. Even though today's topic is a rational number, we should know to recall the concept of whole number and integers. We know the properties of integers last year we discussed about in class. Even though we have to recall to know about integers. If you know that these two topics only, we can easily work out the rational numbers. That's why I am going to choose this topic now. Now, these are the basic properties which we are going to apply it. So just go through once. Closure properties under additions. Last year we discussed over. So it's the basic note how we are going to solve it. For example, numbers, whole numbers, integers, rational numbers are there. It is in the format of addition, subtraction, multiplication, division operations also represents. So whole numbers, integers and rational numbers satisfy the additions, except whole numbers, integers and rational numbers satisfy the subtractions. All the three will be satisfied in multiplications and in divisions, whole numbers and properties and integers and rational numbers are not satisfy the closure property. So how? Let me check out over. We'll wait for that. And commutative property and associative property under the addition of whole numbers, integers and rational numbers. So check it over there. Additions, subtraction and multiplication, division like the same operations. Whole numbers will satisfy addition and multiplications, integers will be satisfy addition and multiplications, rational numbers will satisfy addition and multiplications. All the three cases is not satisfy the subtraction and divisions. So how it will be? So that's what we are going to work out today classes. So before that we should know what is mean by closure property. Closure property. So what is the definition of closure property? So check it over here. So we have one more topic. A set is closed under an operations. Set is nothing but just a format of set me. So a set is closed under an operation if and only if the observations, so operations of any two elements in the sense A and B or something you can consider, two elements of set produced another elements in the same set. If the operations produced even one elements outside the set, the operation is not closed. Okay, have you understood this topic? Closure property. So it's nothing but it's very simple topic. I will explain you how to solve it and what is the meaning of this. For example, closure property. So for example, we will take the three operations as I shown there. So there is three operations is there. One is natural number. Sorry, minute. So we are discussing about the topic is whole numbers, integers and rational number. For example, if I add two whole numbers, the whole number, if I added the two whole number, I will get the result of the same whole number only. If I got any number out of the whole number, for example, negative number or integers or anything we got it mean, then the set is false. So that's what the meaning that. So how they explaining will come to that. So this chapters we are going to explain it now. The whole number. This is what the closure property of whole numbers, integers and followed by a rational number. Okay, whole number. So whole number, closure property. Whole number we are representing in the format of W. So as we know that very well. So addition of operations of two whole numbers A and B is give the resultant of whole numbers. For example, 2 as A, 0 as the B, 2 plus 0, it will give the resultant of 2. 2 is a whole number. So 2 is a whole number. So obviously the addition of properties will be satisfied. The properties is satisfied. Already we have the discussion over. So we have the topic, the whole number addition properties will be satisfied. The second one will be that subtraction of the operations. A minus B. If you subtract two whole numbers, we subtract a two whole number, we should get a whole number. If we are not getting the whole number, then the resultant, the statement will be false. For example, 3 minus 6. If you subtract 3 from 6, 6 from 3, you will get the answer is minus 3. But minus 3 is not a whole number. Minus 3 is a integers. For example, 6 minus 3 means we will get the answer as a 3. But it will not come to the all the cases because it's an identity. It should be satisfied all the properties. If one property is fails, then definitely will be not satisfied over. So now the next one will be the multiplications. Multiplication of two different numbers. For example, A and B will give the resultant of whole numbers. Any number multiple with two whole numbers. 7 into 0 will be 0. 5 into 2 is equal to 10. So if you multiply any two whole number, the resultant will be a whole numbers. The next one will be a division. Division of two numbers, A divided by B, which is not equal to the whole number. Example, 3 divided by 4, which is nothing but 0.75. So 0.75 is a decimal number. Decimal number not in the format of the whole number. So that will be not satisfied. So according to the sum is always a whole number. The difference is not a whole numbers. The multiplication of two numbers is always a whole number. The division of two whole numbers is not a whole numbers. That's what the statement is proved over whole numbers properties. So the next one will be the integers. Integers will be represented in the format of Z. So how could you represent its additions? So A plus B, we know the integers. Integers mean positive number, negative number along with 0. So A plus B is equal to integer number. We should get an integer number. So 2 is an integer, minus 1 is a negative integer. So we'll get the answer, sum of the two, we'll get the answer as 1. So according to that, it is the integer number. The second one, subtraction, A minus B is equal to Z, which means if you subtract the two numbers, we should get the integers. So for example, 4 minus 6 is equal to minus 2. Minus 2 is the integer because integers have negative numbers also. So next one will be the multiplications. Nothing but A into B is equal to Z. Mean multiply the two numbers, we will get the integers. We are getting 7 into minus 1 is equal to minus 7. Minus 7 is a integers. So it will satisfy it again. Now division. If you come to the division, A divided B, we should get as an integer, but we are not. The example is 7 divided by 5 is equal to 1.4 because 1.4 is a fraction, decimals. Decimal will not include integers. So we know that decimal is a non-integer type. And for example, we could say that, sir, if we instead of that, I can say 14 divided by 7. I can get the resultant as 1 7s are 7, 2 7s are 14. So I am getting the integer number, but not always, because in this case it is true, but this case it's fail. So all the times, so we are not supposed to get all the time when you are dividing the two integers, we are not supposed to get the integers. That's what representing the integers properties. So addition satisfied, subtraction satisfied, multiplication satisfied, but division is not satisfied. So that's what we are going to explain it. The sum of always integers, the difference of two integers is also integers, but the multiplication of two integers is also an integer, but the division of two integer is not an integer because this time is satisfied, here it is not satisfied. Okay, fine. Now we can go for the closure property of rational number. So closure property of a rational number will be satisfied over rational numbers in the format of Q. We have quotient numbers. We are telling us a quotient number. So addition, subtraction, multiplication, division. If we add the two rational number, we should get a rational number. For example, 1 by 2 plus 4 by 5, we are getting 13 by 10. Because the denominator is not same, we know the fractions rule. So denominator is not same, we have to take the LCM. Once you take the LCM, here 10. So you have to multiply here with 5 by 5. Here we have to multiply with 2 by 2. So 5 by 10 plus, what is the answer? 8 by 10. 5 plus 8, we will get the answer as 13 by 10. So here it's a rational number. So subtraction. If subtract the two rational number, we should get a rational number. For example, 1 by 2 minus 3 by 4, we are getting the answer as minus 1 by 4. Minus 1 by 4 also a rational number. And multiplications. If you multiply the two numbers, we should get a rational numbers. So 1 by 2 into 3 by 4 is equal to 3 by 8. So here also we are getting the same. But when you come to the divisions, A divided by B is not equal to rational number. How good will be? So you have to find out. The last of this chapter we are going to discuss about two activities. How to multiply two rational numbers. How to divide two rational numbers. The closure property, I am going to give one activity to you. So this is in this case of rational numbers. It satisfies addition, subtraction, multiplication and divisions. So as we know that very well, the sum of two rational numbers is always a rational number. The difference between two rational number also is a rational number. The multiplication of two rational number is also a rational number. But the division of two rational number is not a rational number. Why? Because for example 1 by 3, if you represent as 0.3333 will go on. Because rational number, real number systems, we have rational number and irrational numbers too. For example, if you take the rational numbers, for example 22 by 7. 22 by 7 is the value of pi. Pi number is not a rational number because pi is the irrational number. So this is also in the format of p by q and q is not equal to 0. But this number will not comes under rational number. Why? So these concepts you will learn in your 9th standard. But anyhow, we'll discuss in the next day classes how good we. So okay, fine. So these are the closure property of what we discussed over. Now, next we go to the next one of commutative property. Commutative property of additions will be included of 2. So now, what is meant by commutative property? The name itself indicates commutate, which means exchange, giving and taking the policy. It states that the numbers can be added or multiplied in any order without changing the sum or the product. So commutative property is nothing but it can be changed. For example, I am giving 10 rupee, you are giving 10 rupees. So no problem. So it's exchanging the method of that. So which is how we are going to solve it. We are going to over that. So how could we see that? So whole numbers. So likewise, it has 3 properties as we discussed before. Whole numbers, integers and rational number. The reason why we are explaining whole number integer is for your reference. Because we are going to work out the rational numbers. So addition. So if you take the properties a plus b which is equal to b plus a, which means we are exchanging the numbers. The change in order of two numbers. The change in order of two numbers. A plus b is changing into b plus a. But it should not change the result. For example, it is equal. For example, 1 plus 5 is equal to 5. 1 plus 4 is equal to 5. Similarly, 4 plus 1. If we exchange 1 and 4 to 4 and 1, we will get the same resultant because we are not changing the sign. Same addition sign. The resultant also will be a 5. So when you come to the subtractions, a minus b is not equal to b minus a. The change in order of two numbers is changing the results. That's why, for example, 3 minus 6 is not equal to 6 minus 3. What is the answer for 3 minus 6? Minus 3. What is the answer for 6 minus 3? 3. 3 and minus 3 is not equal. The both are different. So it is changing the result. So the statement will be not satisfied. The next one, multiplications. A into b is equal to b into a. So which is nothing but we are substituting 7 into 6. It satisfies the results. So 7 6 are 42. If you change the order of the number 6 into 7, which is nothing but the same. In multiplication also it will be satisfy the order. The next one will be in the format of division. The change in order of two numbers give the resultant will be in the change because a divided by is not equal to b divided by a. For example, 2 is a whole number divided by 4 which is not equal to 4 divided by 2. 2 divided by 4 we are getting the answer as a fractions and 4 divided by we are getting the answer as a 2. But the both numbers are not equal and this will be not satisfy the whole number properties. So when you come to the next one of integers, the commutative properties of integers. So in addition of operations, the changes of in two orders, a plus b is equal to b plus a. It satisfies that. So which is nothing but, for example, 5 plus minus 1. So 5 is the numbers, positive integer, minus 1 is the negative integers. Is give the resultant as a 4. Similarly, if you exchange the numbers, so minus 1 plus 5, which give the resultant the same of 4. So when you come to the subtractions, a minus b is not satisfy the rule of b minus a. For example, 8 minus of minus 2. So if you subtract the two numbers 8 and minus 2 by minus, so it will not give the resultant of the same, because 8 minus of minus 2 will give the resultant as a 10, and minus 2 minus of plus 8 will give the resultant of minus 10. So which gives it's not equal, because 10 and minus 10 both are integers. Even though it's integer, the resultants are not equal. So when you come to the multiplications, so the change in order of the two numbers does not changing the results. For example, a divided by b, a into b is equal to b into a. 7 into minus 3, which is equal to the resultant of 7 3s are 21. Similarly, minus 3 into 7, the resultant will be as 21. So when you come to the divisions, a divided by b, which is equal to not equal to b divided by a, which gives the same resultant as 7 divided by 5 is gives the resultant as 1.4, where 5 divided by 7 gives the resultant as 0.7. This is a fraction, decimal, this is also decimal. The both numbers are not integers, even though the both numbers are not same. So it will not satisfy the rule of commutative property. So now, as the rule, addition of commutative for integers is satisfied, subtraction is not commutative for the integers, and multiplication is commutative for integers, and division is not commutative for the integers. Now we can go to the next topic of rational numbers. So commutative property of rational numbers. So the change in order of the numbers a plus b, which is equal to b plus a, will satisfy. For example, 3 by 7 plus 5 by 7, the resultant give us 8 by 7. When you have the same denominator, so for your convenience, I'm take the easy number. So same denominator, so adding the numerator 8 by 7. If you change the order of the numbers, 5 by 7 plus 3 by 7, even though we're getting the resultant of 8 by 7. When you come to the second part of the subtractions, a minus b is not satisfied b minus a, where 5 by 6 minus 2 by 3. If you do that sum, because the denominators are not equal, we have to find the LCM. When you find the LCM, the resultant will come as minus 1 by 6. 1 by 6, because we have to multiply with the 2 by 2. LCM is 6. So 2 2s are 4. So 4, 5 by 6 minus 4 by 6. The resultant is 1 by 6. When you do the same over here, when you are changing the numbers, so 2 by 3 minus 4 by 6 will be with the resultant of 4 by 6 minus 5 by 6, which gives the resultant of minus 1 by 6. So where 1 by 6 is not equal to minus 1 by 6. So that's why the resultant is not satisfied. When you come to the multiplications, a into b is equal to b into a. So minus 3 by 5 into 8 minus 8 by 11 is give the resultant of 24 by 55. As I told you, I will give an activity regarding this. So minus 3 into minus 8 is equal to 24. Product of numerator by product of denominators. So if you exchange the letters also, numbers also, 8 minus 8 by 11 into minus 3 by 5 will give the same resultant. When you come to the divisions, a divided by b, which is equal to b divided by a. So 8 divided by 11, 8 by 11 divided by 4 by 5. The resultant is giving us 4 by 10 by 11, and which is not equal to 11 by 10. When you exchange the order of the numbers, it will changing the result. So division of rational number is not satisfied. That is what we already have the discussion of commutative property. Commutative property, whole in rational numbers and multiplications, addition and rational numbers only will satisfy. Remaining parts will not satisfy. As I told you that addition is commutative for a rational number. Subtraction is not commutative for the rational numbers. Multiplication is commutative for rational numbers, and division is not commutative for the rational numbers. Okay, fine. Now we are going to work out the third category of Which next topic is associative property. So like the commutative property, associative properties also will not satisfy for the rational numbers and whole numbers, integers, subtraction and divisions. It will satisfy only addition and multiplications. Likewise, the previous concepts I am going to explain the same to you people, because then only you can get a basic knowledge. Associative property, the associative property state that in addition, when we add more than two numbers, the grouping of the addend does not change the sum, and similarly for the multiplications. This is the definition, so I will explain the details in brief. So when you come for the whole numbers, associative property for the whole numbers, so like the same addition, a plus b plus c, a plus b plus c, which is equal to a plus b plus c. So when you changing the grouping of order and subtracting additions, the resultant will not change. For example, 1 plus 2 plus 3 is called 2 plus 3 is nothing but 5. So 1 plus 5 is resultant is a 6. But when you change the grouping of order in sum, so 1 plus 2, initially we have 2 plus 3, but here we are changing the order of 1 plus 2 plus 3 is give the answer of 1 plus 2 is a 3. So 3 plus 3 is nothing but 6. It gives the both statements are true. So which means of, so addition of associative property for the whole number is satisfied. When you come to the subtraction, the grouping of changing of order in subtraction will not satisfy. For example, a minus b minus c is not equal to a minus b minus c, which means, for example, 4 minus 5 minus 1 is equal to 5 minus 1 is nothing but 4. So 4 minus 4, 0. But when you change the group of the subtractions, 4 minus 5, initially we have 4 minus 5 minus 1, but when you changing the order of this, 4 minus 5 minus 1, we'll get the answer is minus 1 minus 1, because 4 minus 5 is equal to minus 1. So minus 1 minus 1, the resultant is minus 2. So the resultants are not same. So subtraction of associative property is not satisfied for the whole numbers. Similarly for the multiplications, a into b into c is equal to a into b into c. A into b into c is equal to a into b into c. So when you take 7 into 6 into 2, 6 into 2 will be 12, 12 into 7 will be 84. When you change the group of numbers, 7 into 6 into 2 is equal to 7 into 6, 42, 42 into 2, which is nothing but 84. That's what we are getting the resultant of same. So associative property of multiplication for the whole number will be satisfied. When come to the divisions, as we know that division will not satisfy. A divide b divide c is not equal to a divide b divide c. So when you come to the problem, 3 divided by 2 divided by 4. So 2 divided by 4 is nothing but, we are writing like this. When you take the answers over, so simplify the resultant, we'll get as a 6. So the simplification, already you studied in the last year classes, how could you divide the two fractions when we have the division and multiplications. Even though I explain you, when you have the different numbers, I will give an activity. In those activity, I will explain you everything clear how to solve this problem. Now, 3 divided by 2 is into divided by 4. So 3 divided by 4. So now I explain you how to do that. 3 divided by 4 is nothing but 3 by 2 divided by 4. So when you change the division into multiplication, we will take the reciprocal of the number. Reciprocal means interchanging the numerator denominator. That's what we are doing over there. When division changes the multiplication, taking the reciprocal of it. Reciprocal means 4 by 1 will be changes 1 by 4, which is the resultant of 3 by 8, where the resultants are not equal. So that's why the whole number for the associative property division is not satisfied. Now when you come to the integers, similarly like the same statements of addition, a plus b plus c is equal to a plus b plus c. The grouping of numbers if change, the resultant will not change. For example, 5 plus 6 minus 6 minus 4. Minus 6 minus 4 will satisfy the statements of 5 plus minus 6 minus 4 is nothing but minus 2. So 5 plus minus 2 is equal to 3. So when you change the groups, 5 minus 6 plus 4, which is equal to minus 1 plus 4. If you add the sum, minus 1 plus 4, so greater number sign and subtraction, the resultant will be 3. So addition of integers in associative property will satisfy. When you come to the subtraction, it will not satisfy, as we already know that. So now how to solve it? The example you have to see that 5 minus 6 minus 4. We are taking the same number. 5 minus 6 minus 4 is equal to 5 minus 2, because 5 minus 6 minus 4 is equal to 2, so which is resultant as a 3. So when you change the group of the number 5 minus 6 minus 4, the resultant will be 5 minus 6 will be minus 1, minus 1 into minus 4 is equal to minus 5. It will, the resultant are not equal, so it will not satisfy. So associative property of subtraction for the integers will not satisfy. Now when you come to the next one of multiplications, so multiplication for the integers for the associative property is a into b into c is equal to a into b into c. So when you come to the example, 4 into minus 1 into minus 3, so 4 into minus 1 minus 4, minus 4 into minus 3 minus plus 12, minus into minus plus, so 4 into 3 12. When you come for the next one, interchanging the numbers, 4 into minus 1 into minus 3, minus 1 into minus 3 will be 3, so 4 into 3 will be 12, so it will satisfy, the resultant will be equal. So associative property for integers in multiplication is satisfied. Now next, in divisions, so a divide b divide c is not equal to a divide b divide c. So for example, 10 divided by 2 divided by minus 5. So when you change, as I told you how to make it the numbers, to 2 divided by minus 5, so it's the number, so how could you take it off? 2 divided by minus 5, so will be in division. So this decimal already we have worked out over here how to solve it. So when decimal is coming, divided division changes the multiplication and reciprocal of these terms. So 2 by minus 5 will be changes minus 5 by 2, which is nothing but minus 25. So when you do the exchange of numbers, 10 divided by 2 is equal to 5, 5 divided by minus 5, the resultant will be 1. The statements are not equal, so division for the integers in associative property is not satisfied. So don't think that I am going too fast and too big problems. It will be easy for you when you go through that. If you have a doubt, you can go through the video once and twice, you will get to know that. So any doubt, you can put a notification of comments, I will help you for that. So the last one of rational number in associative property in addition is a plus b plus c is equal to a plus b plus c. So when you take the rational numbers of 1 by 5 plus 2 by 7 plus 1 by 3, so these two numbers first you have to solve as the bracket rule. So 1 by 5, so take the LCM. LCM will be, what is the LCM for this number? 35. 35, when you solve this problem, when you add it with this fraction, you will get the answer of 86 by 105. So if you have the idea, last year we recorded in fractions, just go through it and try to solve the problem. You should get the answer as 86.105. So when you come to the next one of subtraction, so exchanging the order of this number, 1 by 5 plus 2 by 7 plus 1 by 3. If you take this fraction, exchanging the groups, you will get the same resultant. So rational number for the additions in associative property is satisfied. When you come for the subtraction, a minus b minus c is not equal to a minus b minus c. So 4 by 9 minus 3 by 2 minus of 1 by 3. So if you solve this problem, you will get the resultant as minus 75 by 18. So when you take over, exchanging the numbers, 4 by 9 minus 3 by 2 minus 1 by 3. If you do the solvation of problem by taking the LCM and solvation of problems, you will get the resultant as minus 39 by 18. So though the resultants are not same, so associative property for the subtraction in rational number is not satisfied. So now you can come for the next one in multiplications. A divide b, a into b into c is equal to a into b into c. So this will be satisfied as the rule what we know that. So 3 by 8 into 1 by 9 into 5 by 8, 5 by 7. If you solve that, bracket mean very simple for us, because 1 5s are 5, 9 7s are, you have to get the answers over, because product of the numbers mean product of numerator by product of denominator. You will get the answer as 15 by 504. So when you exchange the numbers also, 3 by 8 into 1 by 9 will be, so 1 3s are 3, 8 9s are, get the answers and multiple with the same 3 into 5 and the resultant with the 7, you will get the answer is 15 by 504. So the resultant will be same. So associative property for the rational number will be satisfied. When you come for the next of division, so a divide b divide c is not equal to a divide b divide c. So 3 by 5 divided by 2 by 5 divide 2 by 5, 2 by divide by, you will get the resultant as a 1. So for you I take the simple problem. So 3 by 5 will be the answers. If you change the number 3 by 5 divided by 2 by 5, so change like the same, like as I told you that if you division mean, you have to change the sign and take the reciprocal of the second terms and you will get the resultant. And again you have to work out the same, division changes the multiplication, changes